Hi everyone, for this video we are going to talk about simplifying radicals. This is going to be with numbers inside of the radical sign as well as variables. We do not have a note taker, so you're going to want to grab something to take these notes on. So first let's start off with talking about the parts of a radical. So you might have heard a lot of people say like the square root sign or the cube root sign. Technically it's called a radical sign and it looks like this. And so that sign itself is the radical, and then what is inside of the radical sign is the radicand. So there are three requirements to identify that radicals are in simplest form. The first one is that no perfect squares other than 1, because 1 is a perfect square, are the radicand. The second requirement is that no fractions are in the radicand. And lastly, no radicals can appear in the denominator. So those are the three requirements. Before we can start simplifying radicals, we need to identify some of the perfect squares. It's good for you to know the first 15 by heart. So let's go ahead and identify them. So 1 squared gives us 1, 2 squared gives us 4, 3 squared gives us 9, 4 squared gives us 16, 5 squared gives us 25, 6 squared gives us 36, 7 squared gives us 49, 8 squared gives us 64, 9 squared gives us 81, 10 squared gives us 100, 11 squared gives us 121, 12 squared gives us 144, 13 squared gives us 169, 14 squared gives us 196, and 15 squared gives us 225. So even though you can obviously use Desmos, it is nice to know these first 15 perfect squares because it just makes the process speed up a little bit. All right, so let's go ahead and start simplifying some radicals. We're going to do a few examples. So this first one, let's go ahead and write it down, and it's good for you to practice this. So number 1 is the square root of 48. So 48 is not a perfect square. It's not in our list above. So we're going to start off dividing 48, and we're going to try to divide it by the largest perfect square possible. So obviously we can't divide it by 36 or 25, but we can divide it by 16. So 48 divided by 16 is 3. So you're going to break that up just like I did and write the square root of 16 times the square root of 3. Well, we know that the square root of 16 is 4. So we can take that 16 out of the radical sign and we can write the 4 on the outside and then put the 3 on the inside. So this represents the square root of 48. All right, let's do another number. Let's do the square root of 240. So we're going to work our way down our perfect squares. So we can't divide it by 225. We can't divide it by 196. We can't divide it by 169. We can't do 144. We cannot do 121. We can't do 100. We can't do 81. We can't do 64. We can't do 49. We can't do 36. We can't do 25. But we can divide it by 16. So when we divide 240 by 16, we get 15. So that means that the square root of 16 times the square root of 15 gives us a square root of 240. And so we're going to do the same thing like we did earlier, and since the square root of 16, since 16 is a perfect square, we're going to take it outside of the radical sign and then leave that 15 inside. All right, so now let's see an example that's a little different. So we have 20 inside of the radical sign. So let's try, let's look at our perfect squares. Well, the largest perfect square that we can divide 20 by is 4. So I'm going to split that up as the square root of 4 times the square root of 5 would give us the square root of 20. So when we take that 4 outside of the radical sign, it becomes a 2. And we're going to leave that 5 on the inside. And whatever we bring outside of the radical sign, we're going to multiply it by whatever is also already on the outside of the radical sign. So we're going to end up with 6 square root of 5. All right, moving on to a few more examples. So we have the square root of 2 times the square root of 14. Neither 2 nor 14 can be divided by perfect squares. So let's actually multiply those two together. And when we do, we get the square root of 28. Now let's try to divide 28 by some perfect squares. So 28 the largest perfect square it can be divided by is 4. So the square root of 4 times the square root of 7. And so let's go ahead and take that 4 out of the radical sign, and when we do, it becomes 2. And then inside the radical sign, we have a 7. All right, here we have a fraction inside of the radical sign. So what we can do is we can rewrite it by having the square root of 7 in the numerator and the square root of 16 in the denominator, so kind of breaking it apart. And we can identify that 16 is a perfect square. So in the numerator, we're going to keep 7. 7's prime. We can't do anything with it. And we're going to reduce that to 4 in the denominator. Okay, so now we're on to number 6. We have the square root of 18 over 3. So 18 can be divided by a perfect square, and that is 9. So the square root of 9 times the square root of 2 gives us the square root of 18. 9 is a perfect square, so that can come out of the radical sign. So now our numerator is going to be 3 square root of 2, and in our denominator we have a 3. Since we have a 3 in our numerator and we have a 3 in our denominator, those cancel out. And so our simplified version is the square root of 2. All right, so now we're on to number 7. If we notice inside the radical sign, we have 80 in the numerator and 45 in the denominator. These are both divisible by 5. So let's go ahead and reduce the fraction and then work with simplifying it even farther. So 80 can be divided by 5, and when we do, it's going to give us 16. And then 45 can be divided by 5, and that will give us 9. Now let's rewrite this as a radical sign of 16 in the numerator and a radical sign of 9 in the denominator. So the square root of 16 is going to reduce to 4, and the square root of 9 reduces to 3. And we're going to leave that improper. All right, now let's switch gears a little bit and let's do some practice with perfect cubes. So this is when you multiply something by itself 3 times. Okay, so some of our perfect cubes, 1 cubed is going to give us 1, 2 cubed gives us 8, 3 cubed, gives us 27, 4 cubed gives us 64, 5 cubed gives us 125, 6 cubed gives us 216, 7 cubed gives us 343, 8 cubed gives us 512, and let's stop there. So 1 through 8 of the perfect cubes are good to know by heart because they do kind of come up frequently. As always, you can use Desmos, but it's nice to know those. All right, so let's do some practice problems with these. So you want to divide. We have the cube root of 56. We want to divide it by the largest perfect cube possible. So the largest one would be 8. And you want to make sure that you write that 3, otherwise it is a square root. So 8 times the cube root of 8 times the cube root of 7 gives us the cube root of 56. 8 is a perfect cube, and when we take it out of the radical sign, it becomes 2. This simplifies to 2 cube root of 7. All right, let's take a look at number 2, so the cube root of negative 162. So the largest perfect square that negative 162 can be divided by is negative 27, and I want you to keep that negative with the 27 rather than the other factor that we're going to have. So the cube root of negative 27 times the cube root of 6. And so since 27 is a perfect cube, when we take it out of the radical sign, it is going to become negative 3. We're going to bring the negative with it. And then inside the cube root, we have 6. All right, let's do 2 more examples. So we have negative 2 cube root of 750. And so we need to think, what is the largest perfect cube that 750 can be divided by? And that is 125. And so the cube root of 125 times the cube root of 6, would give us the cube root of 750. And so when we take 125 out of the cube root, it becomes 5. And we have 6 still in the cube root. And so now we do negative 2 times 5, and that gives us negative 10. And then inside the radicand is 6. All right, last one. We are going to be multiplying negative cube root of 28 times the cube root of 4. So 28 times 4 gives us 112. We're going to keep that negative sign on the outside. The largest perfect cube that 112 can be divided by is 8. 8 times 14 gives us 112. And when we take that 8 outside of the cube root, we are going to get 2. And we're going to keep that negative in front of that 2. There we go. All right, so the last thing that we're going to do is we're going to simplify radicals with variables. And our rule is we can only take them out in groups of 2. And when we take them outside, we're just counting. Its new exponent is going to be how many groups of 2 there were. So for example, let's look at number 1. Let's rewrite it as the square root of x times x, because that's equal to the square root of x squared. And let's take it out as a group of 2. And since there's only one group of 2, this is x to the first power, and we don't need to write it like that. We're just going to write it as x. Okay, so now let's try the second one. Let's rewrite it. And let's rewrite it as the square root of x times x times x times x times x. And let's take them out in groups of 2. And we cannot take that one out because there's an odd amount. So we have 2 groups of 2, so that means on the outside we're going to have x squared, and then inside the radical sign we're going to have that leftover x. All right, let's do 2 more examples. So number 3, we have the square root of 63b squared. So let's first work with the square root of 63. The largest perfect square that it can be divided by is 9, because 9 times 7 gives us 63. When that 9 comes out of the radical sign, it becomes a 3. And then inside the radical sign, we're left with 7 and b squared. Well, we have b squared, and we know that that means that we have 2 b's, and we can take them out in groups of 2. So that means that we'll have one group of 2b's. So on the outside, we can write 3b, and then in our radical sign, we only have 7. All right, last one, we've got it. So we have 8 square root of 320x y to the 4th power. Let's go ahead and work with that 320 first. So the largest perfect square it can be divided by is 64. 64 times 5 gives us 320. So when we take 64 outside of the radical sign, it becomes 8. And so we have 5 inside, we have x, and we have y to the 4th power. 8 times 8 gives us 64. Now let's work with what we have inside of the radical sign. So that x has an exponent of 1, and so since that's an odd exponent, we can't do anything with the x. However, the y has a even exponent of 4. 4 would give us 2 groups of 2. So on the outside of the radical sign, we can write y to the 2nd power, since 4 would give us 2 groups of 2, and then inside we have 5x. All right, good job, guys. This is a pretty difficult skill. We'll talk more about it in class.